you have this in front of you here. I just handed it out. I'm going to do a little bit of review over the last couple of days, and I'm going to talk to you about velocity. So remember, review here. Displacement is a change in position. Delta D is x2 minus x1, where you take the final one, subtract the initial one. Remember doing that, Tiffany? Okay, we did that the other day. Final position, subtract initial position. Here's an example as a review. Object located on a number line at plus 12. Moments later, it's at plus 5. What is its displacement? So delta D is x2 minus x1. What is your x2 value? Trouble, Travis? Yeah. So what's the displacement? We've got to go to the final position, which is 5. The final, moments later, it's the final position is at 5. It's not necessarily going from left to right. So that's going to be 5 minus 12, which is minus 7. And you can't count there, can you? Because I drew that number line like that. Minus 7. Right? Displacement. You have to be able to do that. Okay. Negative displacement is to the left. Positive displacement is to the right. Now, I didn't talk a lot about change in time, but I should just briefly touch on it here. Change in time is the same. It's the final minus the initial, right?
Are we going to have to know that one?
The change in time? I mean, you're going to have to be able to do it, but I mean, you're probably not going to have to write that formula, right? And I haven't talked to you about, is this on yours?
Yeah.
This is on yours, I think?
Yeah, we have to write.
Okay, good. All right, so quickly let's talk about time instant and time interval. This is overly complicated. Like I made it more complicated than it really needs to be. So time instant versus a time interval. An instant is simply a single reading of a time, a single look at the clock. Tiffany, you writing stuff down? Because there's blanks there you need to fill in. A single reading of a time. An example would be 1:21:38. You look at the clock, and that's the time. A single instant of time. The clock is read only once. This might be used in a situation where you want to know where a car is at a certain instant of time. Where is it at a single instant in time? Right? One reading of the clock.
Can you get rid of that box?
Yeah. Okay, so single instant of time. So here's an example of it in use. Following picture is taken when t is equal to 3 seconds. Where is the car at this instant? Actually, where is it? It's at position plus 4. It's a single instant in time. Everyone knows what instant means.
Yeah.
Okay. What is the difference? What is an interval? An interval is 2 readings of time. It is the difference between 2 instants. The difference between 2 instants. The clock is read 2 separate times. Okay, so the clock is read 2 times. What's T1 in this case? What time is it? 1:21, time 2, 1:32, right? 2 different instants. How long is this interval? 11 minutes. You subtract, right? 11 minutes. You just subtract. The interval is T2 minus T1. This is called a change in time, and in this case, the interval would be 11 minutes. 32 minus 21. Okay, so here's the example. Time intervals are used when you want to know how far a car travels over a period of time. Example here, the car travels from 1 to 4 in 2 seconds, right? So it's an interval of time. I think everyone gets it. Another way to think of time instant is like a picture, while time intervals would be more like a movie or a video. Right? Time instant can also mean a single position of an object. Time interval means 2 different positions if the object's moving. Okay, let's jump right to velocity. So now we're on the second page. Now we're on the second page. You got this? You're good? Yeah, Mike? You say I don't have this. There you go. All right, so velocity is simply how fast an object is moving and in what direction. How fast and in what direction. The symbol for velocity is the letter V. To determine the velocity, we take the displacement and divide by the time it takes to move that distance. Here's the formula. Will you need it on your cheat sheet, Charles?
Yeah.
Oh, yeah.
So, okay, this way.
I will wait.
Symbol.
Symbol for... Okay, so you take the displacement that we learned about already, and you divide by delta t. And what's delta t? The change in time, time interval. Divide by the time. Can I move on? Everyone good? Okay, so here's an example. Suppose in this example that the car moves this displacement in 2 seconds. What is the velocity? So what are the steps? You have to find out the time, you have to find the displacement. Doesn't matter what order you do them in. The time interval is, delta t is t2 minus t1, or just 2 seconds. Now the reason this whole interval thing kind of is confusing is because usually t1 is equal to 0. You don't have to subtract 0.
T1 is equal to 0?
T1 is usually, if I just say it happens in 2 seconds, right? There is no clock reading.
So on the test, will it be just 0 then?
There might be a question where it says that the car is at this point at a certain time and the car is at this point at a certain time, right?
Okay.
So then you'd have to, okay, so the time is 2 seconds. What's the displacement? Look at the picture. It started at 1 and ended at 4. 4 minus 1 is 3. The displacement is 3. The time is 2. What do we do? What was the formula? Velocity is distance over time. What's the displacement, Tiffany? What's the displacement? You just wrote it down. Displacement is 3. So we're going to go d over t, so it's going to be 3 over 2. What's your velocity? 1.5. Right? The velocity is displacement 3 divided by the time to 1.5 meters per second. Why is it plus? Because it's moving to the right. It's plus because it's moving to the right. Let's do another velocity example because they're so much fun.
Okay, I need to know how to do
You do need to know how to do this. That's right. Okay, so here's another example. Let's try this one here. This time the car is moving to the,
Let's go down.
which is to the left. So the velocity is going to be
5 and 1.
negative, and it's moving from 5 to 1 in 3 seconds.
Yeah.
Okay. 5 to negative 1. Thank you.
In 3 seconds.
In 3 seconds.
Okay.
So, what's the displacement? It's right there. The displacement, it ends at minus 1. Oh, I gotta make it bigger. Don't I? It ends at minus 1, starts at minus 5, so it's moving 6 to the left. 1, 2, 3, 4, 5, 6 to the left. The time is 3 seconds. displacement over time, so it's going to be 6 over 3 or minus 2.
Oh, no, I don't ask these. Okay.
And it's moving to the left, which makes it negative. Okay, awesome. Okay. You guys try this one. In this example, the car moves this displacement in 3.2 seconds. What is the velocity? I'm going to let you try this one as a try it, and then I'll show you.
And then the displacement is where you, like, not the second, but
It's how far you go and in what direction, right? Final minus initial. Okay, so what's the time interval?
3.2.
3.2. What's the displacement? It ends up at 4. It started at minus 2. 4 minus minus 2, which is plus 6. 1, 2, 3, 4, 5, 6. Velocity is v equals d over t. The displacement is 6. The time is 3.2, and you guys are going to have to help me because I don't have a calculator right here. What's 6 divided by 3.2? 1.875. How about I just say 1.9? Is that okay? Easy enough?
Oh, yeah. But
Oh,
for the 4 and the 2,
yeah.
I get confused on which one goes first.
Well, it's the final, where you end up,
Is what you go.
is where it goes first. It's final minus initial. Final minus initial. Right? If you've got 20 bucks in your pocket, and then a little while later you got 50 bucks, what happened? How much did you increase? Right? You go 50 minus 20. Oh yeah, there's some exercises to try there. And then we're going to do a little walking around here. There was a roll of tape out there. Well, that's got it. Yeah.
I go to the washroom.
Did you do some there? Can you finish up first, Ruth?
I did
You did them all?
go to the washroom.
All right, go quickly.
Oh, nope. Oh, that's what you do. You switch the right and left around.
Might have.
Yeah. I said right and I said the left.
grade 6.
I guess it's because the grades could take grades for science last year. Otherwise, how do I have grade 10 and all grade 11 courses?
There's no such thing as your record.
It's good.
But you gotta do your water. Honestly, it's gonna be lost. How do you find the lost?
That was a decision online, but I do not want to.
This one?
What the heck? I thought you had to do, oh,
We don't know the answer to it. Full-time job managing these laptops.
Yes, I remember when you weren't here. Remember last year? We didn't do a very good job.
Yeah.
well, you know, I've worked a long time, you know.
Drop down.
Four. Serious? Hey, what's up? Some dance cultures. Dude, are we going to that dance thing?
Are we going to that dance thing? Are you dancing?
Powwow?
No, down, I don't know that thing downstairs. Well, I wanna be in there, there's free pizza.
No, then we're probably not going.
No. Even if you were dancing, no one wants to see you
What
dance.
if I learn how to dance? One of those like little
I could dance the shake, 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 shake.
Maybe like if you intercepted a pass, Ruben, and returned it for a touchdown, a little touchdown dance in the end zone?
I did that in rugby last year.
Yeah?
Except I hit the kid and he made a fumble ball and then
Oh.
he just kinda picked up the ball. It is funny, look, he's like weak.
Oh my god.
I pretty much just beat him in the face.
Right.
I was like, boom, you're done. Hey, fuck you. How's your ear? Last
You
year.
do this. What's wrong with it?
Well, why don't you still play it? Why don't you play it? Lawrence is playing.
Rugby?
Yeah.
What else?
That's good.
Action.
Yeah.
Hey, don't play it.
Who else is playing? There's other practice.
Mondays and Wednesdays.
I can like,
Yeah, you should come.
my ear like still bleeds sometimes.
Dude, you just did one practice.
I know. I hurt my ear.
You hurt your ear in one practice. That's hilarious, actually. I'm sorry. Wasn't that me that did that, or was that Blake?
Alex got it. After he kept going back. And after a while, it was like in one right here.
Alex doesn't even play anymore. He got the rookie of the year for somehow. Being lost in over here and being Blake.
Positive is good. Negative is good. There you go.
We let him up and he catches the ball. We let him up by his feet.
Keep going.
The way
You can do it.
There, here, running one.
The only thing I don't like about rugby is the short shorts.
What? So there's a ball there, and
You
it's
know,
called a
like,
big
maybe
scrum,
you
and
can- you can step on it.
you gotta go like this and go as far as you can down, and then there's like a hooker in the middle, and there's me and Leo.
Everybody's like, I'm going rugby now.
To get the ball, and then you hit people.
Are you talking about Charles? You just kick
Fall
the
down.
ball, you said.
Well, I think
Why not put stamina
they're in my way.
Is it you stop in the game?
That's not hitting this.
Doing pause in the game?
Not like
Or
this.
you just like go
But
all on the
I
target?
usually get thrown up. I don't like it. There should be legal hitting in the game. I have to.
There is.
No, you can't go like this and just punch somebody or going like this. You actually have to wrap them in there and go down with it. I don't like that.
I don't like when you wrap them up and bring them up. I feel like
I don't get, yeah, like, I don't get why you have to go down with them. I think you should just be able to hit them and get them to
You don't
go
like the
down.
fact that when you tackle someone, you also get tackled.
Basically, that's basically what happens. Because you have no choice, because you have to fall with them.
Why like Steven always ends up in the
Well, me and Steven last year, I think me and Steven combined household like, I don't even know, I think it was 30 end zone penalties because all me and Steven did was just hit them with our shoulders. Shoulders right there. And I think me and Steven, I broke somebody's wrist and Steven just hit him on the shoulder.
Okay, so let's quickly go through these here and we'll do, hey, now we can go through pizza. Oh, I was still recording. What do you know? All right. Positive velocity means what, Charles?
Right.
Moving to the?
Right.
Moving to the right. Dance it for us, Charles. Moving to the right. That's left and right.
No.
Would that mic be able to hear us?
What mic? This mic? Yeah. Yeah.
Put that mic at school again.
I do it every day, Ruben.
No, I want to listen to it.
I do it every day. I will.
Where's the mic?
Right here, webcam.
Oh, that's
Negative velocity means moving to the?
Right,
To the left. Do it for us, Charles.
yeah. If I do the hip thing, you always say that move to the right. So I gotta go like, you know?
Who would have known when I got Charles dancing in science class today? What'd you do in science? What'd you do in school today? Watch Charles dance.
Yeah. I was dancing in a band.
Okay. Given the following displacements and time intervals, calculate the velocity, circle the direction it's moving. So in every case, you take the displacement and divide by the time. So it's 20 divided by 5, which is? 4 meters per second. Minus 30 divided by 10?
Negative 3 ms.
Minus 3 meters per second. 45 kilometers divided by 2 hours.
22.5
40.
H.
Yeah. 22.5 km per HR. kmh.
Hey, we gotta do the right and left thing.
Yeah. So this is positive, so that's right,
Left,
left, right, just like the Army.
left,
Right, left, right. Right? I don't.
left, right, left.
Oh.
I didn't say that.
Left, right,
Like,
left.
They can't start on right?
Right, left, right, left.
They always start with left. Is that right? I don't know. Do you know any cadets? I don't know.
I know Thomas Fisher.
On your right. On your left.
He probably didn't go with this.
I don't know.
After a while.
Okay, here's the ones with the cars. Calculate the velocity, circle the direction it's moving. Well, clearly the car is moving to the
Right,
right.
positive, so left.
Ironically, right is on the left down here.
Yeah, I know.
You notice that? Oh, is that what you meant by you put it backwards?
Yeah, 'cause I was like,
Oh.
the right, and I circled the right answer.
Which is on the left.
Yeah.
Gotcha. Okay, what's the displacement? I went from 1 to 4, so the displacement is 4 minus 1 is 3. The time interval is 2, so that's going to be
Like,
3 over 2, 1.5 meters per second.
oh, I'm so good to actually get it.
It's not hard. P1, P2. Displacement here, start at minus 3, ended at 4. 4 minus 3 or 7. Interval is 3.
It's right.
7 divided by 3. 2.3 meters per second.
It is right.
This one's to the left.
Get it?
Oh, I was looking at the bottom one here.
Woo.
To the right.
Get up. Right.
C.
To the left.
You're wrong.
This one's to the right, right? That's positive. Okay, displacement here. It ends up at minus 3. So minus 3 subtract 2 or minus 5.
That's what is left.
Interval is 4 seconds. Minus 5 over 4. Minus 1.25 meters per second. which is to the left.
On the right.
Put on the right.
There you go.
Right you are, Ruben. Is that it?
Yeah.
Okay, so now there's